This is the second question and the first question of integration and antiderivatives in the 2016 exam multiple choice. The question is direct integration, so it's x squared x cubed minus 1 to the power of 10 dx, and we need to integrate it. We will integrate it using the substitution method. So u is equal to x cubed minus 1, and so du over dx is equal to 3x squared, and so dx is equal to du over 3x squared. So the integration is x squared multiplied by u to the power of 10 du over 3x squared, and we cancel x squared with x squared, so we have now 1 over 3 u to the power of 10 du, and u to the power of 10 is u to the power of 11 over 11 multiplied by 1 over 3, so it is plus c obviously, so it becomes x cubed minus 1 to the power of 11 over 33 plus c, and this is the final answer. This is question number 8 about direct integration and antiderivatives. We will solve it by direct integrations and by u substitution. So u is equal to x squared plus 9, and du over dx is equal to 2x, dx is equal to du over 2x. So the integration from 0 to, still unknown, from 9, because we substitute x here to find the u, and to 25 because it's 4 squared plus 9, x over u to the power of half divided by dx over 2x. We cancel the x's and we get from 9 to 25 u to the power of negative 1 negative half du. So the answer is equal to from 9 to 25 u to the power of half divided by multiplied by 2. So the answer is 25 square root of 25 minus square root of 9. Of course we forgot this one, the half outside this half, so the half cancels with 2, so it's the square root of 25 minus square root of 9, which is 5 minus 3, so the answer is 2. This question is also about direct integration, and we need to find the solution of the problem, the general solution, since we don't have limits and boundaries. So it's the integration of e to the power of x plus e dx is also equal to the integration of dx plus the integration of e dx. Integration of e dx is equal to e to the power of dx. Integration of e is ex plus c.
I will be solving two questions about integration from the 2016 AP exam. First of all, what is integration? Integration is splitting any type of graph, for instance what we have here, into smaller regions. And one technique that can be used is Riemann sum, as shown here. And we can find the whole integration by splitting the whole graph into smaller rectangles. For instance, here it's the technique used is Riemann sum, which is a form of integration. The question I'm going to be solving is number 10 from the AP 2016 exam. which is x cubed plus 1 to the power 1 over 2, which is square root, times x squared dx. We make x cubed plus 1 equal to u, and from that we can find dx, which is 3x squared dx, and we can find the value of dx by dividing 3x squared from both sides, which makes this allows us to write it in terms of u, which turns out to be square root of u x squared du over 3x squared. We cancel both x squared, both x squares, and take out 1 over 3, which makes the integration like this: 1 over 3 integration from 0 to 2 square root of u du. And we can simply integrate, which becomes 2 multiplied by u to the power 3 over 2 over 3 from 2 to 0, and all of this is multiplied by 1 over 3, which equals 1 over 3 multiplied by 2 cubed plus 1. And after finishing the integration, we return the value in terms of x, which when we replace x by 2 turns out to be like this, over 3 over 2 minus 2 multiplied by 0 plus 1, 0 cubed, 3 over 2 over 3, which equals 52 over 9. The other question that I'm going to be solving is 24 from the same exam, from 2017 AP exam, which is -2 to the power 4 f of x power over 8 dx. The average value from point -2 to 4 is equal to 12, from -2 to 4. And as we know, average value equals 1 over b minus a from a to b f of x dx. We can use it. We can use the average value to find the value of x. The question wants us to find the value of f of x, and by using this formula we can find it. So 1 over 4 minus -2 multiplied by integration from -2 to 4 f of x over 8, which equals to 12. Simplifying this becomes 1 over 6 integration -2 to 4 f of x over 8, which equals 12. Don't forget dx. Multiply 6 on both sides to cancel the 1 over 6, which makes it -2 to 4 integration -2 to 4 f of x over 8 dx equal to 72. What I meant was that the question wants the value of the integration of this integration, and given that the average value is equal to 12, and as you know, the average value formula is this, and we replace the values here using the average value formula, and we found this. We multiplied 6 here and 6 here to cancel the 1/6, and then this left us with this, which makes the integration from -2 to 4 f of x over 8 equals to 72.
Now I will explain the topic of antiderivatives and integration techniques. First of all, what is integration, or what are integration techniques? Integration is the opposite of deriving. So when you try to find an integral, you will have to use the reverse technique of finding a derivative. As you can see here, this is how we write an integral. First, we write the integral symbol, which is big S, which means sum, and then the function we want to integrate, then dx, which is slices along x-axis, or along x. Some integration techniques are integration by parts, integration by u substitution, integration using partial fractions. Integration by parts. Integration by parts has its own formula, which is written here as you can see. It is the integral of u dv equal to uv minus integral of v du. Choosing u and the u dv in the first integral must be chosen in this order, which is of Liate, which means logarithms, inverse trigonometric, algebraic, trigonometric, exponential functions. If, for example, if we had x ln x, integral of x ln x, since ln x is logarithm, then it will be chosen as u, and x will, which is algebraic, will be chosen as dv. While in case of integration by u substitution, we have one rule, which is the integral must have both the function and its derivative, or part of its derivative. So in the example here given, we have the function here and its derivative, which is the f prime. So we can use u substitution. We can use u substitution to solve this one. Now we will solve a question. About integration. The question says, what are all values of x for which the integral from x to 2 of t cube dt is equal to 0? So the question says the integral from x to 2 t cube dt is equal to 0 at what functions? First of all, here we will integrate using the normal method, which is the power rule. So we will increase the power, or the exponent, and then divide by the increased exponent. So this integration will be given by t to the power 4 over 4 from x to 2 is equal to 0. So it will be 2 to the power 4 over 4 minus x to the power 4 over 4 equal to 0. Taking this to the other side, we have here here we will, taking this to the other side and divide by -1, we'll have x to the power 4 divided by 4 equal to 4 times 4. So x to the power 4 is equal to 16, root of 4 to cancel the power 4. X is equal to plus minus 2. So the answer, as you can see, is D. Now we will solve another question, also about integration techniques and derivatives. Here it says find this integral, or solve this integral. First of all, we will write 1 over 3x plus 12 dx. First we will simplify it, so it will be 1 over 3 times 1 over x plus 4 dx. Since this is a constant, we can take it out. So it will be 1 over 3 integral of 1 over x plus 4 dx. This integral we can solve it by antiderivatives, because this is the derivative of ln x, which is 1 over f of x, and in this case f of x is x plus 4, so it will be ln of x plus 4, so it will be equal to 1 over 3 times ln of x plus 4 plus c, which is in this case will be b. This is the answer. Now we solved questions using integration techniques easily, and we finished our task. Thank you.
This is question number 7 from the 2017 exam about integration, about the topic integration and anti-differentials. The question says that we have from 4 to negative 10, the integration of g of x dx is equal to negative 3. And from 4 to 6, the integration of gx dx is equal to 5. The question wants us to find the integration from negative 10 to 6 of gx in terms of x. So how can we find it? We will find it like this: from negative 10 to 4 g of x dx plus 4 to 6 g of x dx. We have this one. We have from 4 to 6, which is 5. But from negative 10 to 4, we don't have it. But we have the opposite from 4 to negative 10. So we should multiply this one. We should multiply this one by negative 1, so it will be equal to, it will become 3. So this one is a 3 and this one stays the same, it's 5, so it's 8.
Hello, in this video I'm going to explain integration by substitution. In integration by substitution you have two parts. The first part is the inside function, and the second part is the outside function. Okay, if you see that the outside function is very similar to the derivative of the inside function, then you can use integration by substitution. Okay, what do I mean by the inside function is very similar to the outside function is very similar to the derivative of the inside function? I mean that there's we multiply by a coefficient. We can't multiply by a variable. Now I'm going to solve an example to make this clear. The integral of 2x cosine x squared times dx. Okay, first we need to determine where's the inside function and where's the outside function. This is the inside function and this is the outside function, because this is very similar to the derivative of this. Actually, it is the derivative of this. So after that we make a new function which is called u. U is equal to the inside function, which is x squared. Then we find the derivative of u, so du 2x times dx. So you can substitute this and you can ignore this and put d instead of this. Okay, cosine x squared is u multiplied by 2x times dx is du. Now this is simple integration. The integral of cosine u is sine u plus c, and u is x squared sine x squared plus c. Okay, this is the first example about integration by substitution. I will give you another example. Before giving the other example, I would like to mention this point. When you have most of the time, when you have a trigonometric function with another small function inside, probably this is going to be the inside function and this is going to be the outside function. Okay, let's go to the next part. The next question says the integral of x cubed square root 1 minus x squared okay, and this part we don't have this part, so du over dx is equal to, what is the derivative of this? It is 2x. So du is equal to 2x times dx. Okay, 2x times dx, 2x times dx. So you can substitute this and like you can ignore this and put d instead of this. Okay, cosine x squared is u multiplied by 2x times dx is du. Now this is simple integration. The integral of cosine u is sine u plus c, and u is x squared sine x squared plus c. Okay, this is the first. Hello, in this video I'm going to explain how to solve an integral in an advanced way, and this video is going to explain integration by parts. In integration by parts, you have two types of function. The first function is called u. The second one is called dv. Okay, in this video I'm going to explain how to solve this integral and how to choose u and dv in a correct way. We have a word in math called Liati, and we see which letter comes before the other. If L comes before I, then L is going to be U and I is going to be dv. And we should know the meaning of this word. L stands for logarithmic, I stands for inverse trigonometric, A stands for algebraic, and T stands for trigonometric, E stands for exponential. Okay, imagine that you have two functions. The first function is trigonometric and the second is algebraic. Which one is going to be v and which one is going to be u and which one is going to be dv? If we have trigonometric and algebraic, we are going to go to the word and see which one comes before the other. A comes before t, so A, which is algebraic, is going to be u, and t is going to be dv. Let's give another. So A, which is algebraic, is going to be u, and t is going to be dv. Let's give another. Let's give an example about this question. X cosine x times dx. Okay, this is an algebraic function and this is a trigonometric function, t and a. As we can see in the word Liati, a comes before t, so this is u and this is dv. Be careful because dv is not only cosine x, it is cosine x dx. Okay, after identifying this, we should follow this formula. The integral of u times dv is equal to uv minus integral of v times du. Okay, in this case u is x and v is the integral of cosine x alone. The integral of cosine x alone is sine x minus the integral of v, which is the same as this, sine x. Okay, if u is x, which is going to be du, the derivative of x, which is x times dx, which is 1 times dx, because we decrease the power of this. X to the power of 1 minus 1 is equal to x to the power of 0, which is 1 dx. Now we can see that this is a simple integration. This is a simple integration. This is going to stay as it is. Okay, so x sine x plus cosine x, and this is not a definite integral, so we have plus c. Please don't forget plus c. Thank you. In this video I'm going to solve question 77 from AP Calculus AB exam 2017. Okay, in the question we need to find h of 2 and we have h of 5. Please read the question before solving it. The question says, let h of x be an antiderivative of function which is x cubed plus sine x divided by x squared plus 2, which this is the function x cubed plus sine x divided by x squared plus 2, and h of x is the antiderivative of this function, which is the integral of this function. And here they gave us the condition, and which says h of 5 equals to pi, then h of 2 equals 2. We need to find h of 2, and h of 5 is given as pi. Okay, so we know that the integral from 5 to 2 of the function plus sine x divided by x squared plus 2 times dx is equal to h of the final minus h of the initial, which is the initial condition here, h of 2 minus h of 5. Okay, to find h of 2 we are, and h of x is the antiderivative of this function, which is the integral of this function. And here they gave us the condition, and which says h of 5 equals to pi, then h of 2 equals 2. We need to find h of 2, and h of 5 is given as pi. Okay, so we know that the integral from 5 to 2 of the function plus sine x divided by x squared plus 2 times dx is equal to h of the final minus h of the initial, which is the initial condition here, h of 2 minus h of 5. Okay, to find h of 2 we are going to move h of 5 from this side to the other side, from 5 to 2, x cubed plus sine x divided by x squared plus 2 times dx, and h of 5 is pi, plus pi equals to h of 2. We are going to use our calculator to find the integral of this, and the value is going to be negative 5.867, and this is choice B. Thank you. Hello, in this video I'm going to solve question 81 from AP Calculus AB exam 2017. Please open the question to see the graph and to understand how we have done this question. Okay, we have a graph of f, and we should find the graph of antiderivative of that function f. Okay, first the value of -1 is going to be our initial value in the antiderivative graph, which is it's approximately here. Okay, from the given graph, we can see that the area from -2 to k, where k is the x-intercept, is negative, and the integration is the area under the graph. So if the area under the graph is negative, here the integral is going to decrease until it reaches k. And between k and the y-axis, the area is above x-axis. So from in the original graph, the area is above x-axis, which means that the integral is going to start increasing. And we know when we are going to analyze the graph and see its shape, we know that the area here is approximately the area here from the original graph. So it's going to reach like until it goes 0 from the original graph. So it's going to reach like until it goes 0. Okay, and when it reaches 0, we have area from 0 to f, where f is the x-intercept and the positive x side. As I have mentioned, it is above x-axis, which means that the integral is going to be positive and it's going to increase. Here we are going to have an increase in the integral until it reaches for f. And after f, from f to 2, we have a decrease in the integral because there is negative area. So the graph is going to decrease like this. And the choice that gives us a graph that is similar to this is choice D. Thank you.